Welcome to the proof of the quotient rule. Now, there are some other rules that you will need to know during this. So the power rule, the product rule, and the chain rule. So, let's get into it. So, the first step is to know when to use it. So, in a situation you would have, let's say, 1 over x plus 3, x plus 13, there, it's better there, or x plus 2 over x squared, or what you could have is you could have just a higher constant, so 3 over x, let's say. And this is a situation, these are all situations where you could use the quotient rule. So for this, what you have to do is, to prove it, what you need to do is you need to write the quotient as functions of x. So to find the derivative of f of x over g of x. You may say, well, in the situation of 1 over, let's say, x plus 3, 1 is not a function of x, but it is. F of x could be 1, essentially, as x to the 0 equals 1, but we're just using it in that f of x just to show that it includes stuff such as x plus 3, instead of it just being a single variable there. So the derivative of f of x over g of x being our two functions. So the first step is to show, so f of x over g of x is also equal to f of x times 1 over g of x, as the f of x would go to the top, just like that. And let's just leave it like this for now. But as you can see, because we have a multiply there, which I should really do it like this. There we go. Because we have a multiply, we know we need to use the product rule. So the product rule being the derivative of the first times the second, plus the derivative of the second times the first. So here we can have derivative of the first, derivative of f of x can just be f prime of x, plus, times the second, which is just 1 over g of x. Now this can obviously simplify down, but we'll do that later. There's a terrible x there. There we go. Plus the derivative, the first, which is just f of x, times the derivative of the second. And as you can see, here we have a thing that you may say, well, that's a quotient rule, isn't it? Not exactly. We can use the chain rule here. If we rewrite that, so instead of it being 1 over g of x, it's g of x to the minus 1. We can use the chain rule, because here we have a function raised to another function being minus 1. And the chain rule says that g of x to the minus 1, let me just write it over up here, must be the derivative of the first, of itself, if you were doing it like a power rule, so minus g of x to the minus 2 times, let me do that there, times the inside function derivative, so just g prime of x. So let's clean this up. Let me swap to a different color now, just in the bottom. We can, so let's just do this onto here. So first we know f prime of x times 1 over g of x would be f prime of x over g of x plus, so we have f prime of x times this, which minus to the power of minus 2, that would just be 1 over that squared. So what we have is f of x times minus 1 over g of x squared times g prime of x. What we can do here is we can change it just so everything goes into the top, such that we get, it is just f of x times g prime of x over and this is all minus, I'll just put that at the front of the fraction there, yeah, like that, over the g of x squared. And so we can minus these fractions to make one neat fraction, which we will solve in green. We want to times the top and bottom of this by g of x, such that we get the same denominator. And that allows us to have something all over g of x squared being this here, which is f prime of x g of x times f of x times g prime of x. So here we have the quotient rule, where d over dx of f of x equals f prime of x g of x f of x g prime of x. Slowly running out of that space there. All over g of x squared.